Hey everyone! Welcome back to the channel. If you're into coding, problem solving, and smart programming tricks, you're in the right place. Subscribe and level up with Code with Ram.
Today we're solving a very popular interview question, longest common prefix. In simple terms, we need to find the starting characters that are common across all given strings. Let's understand this step by step. You are given an array of strings, and your task is to find the longest prefix that is common to all the strings. Now, what is a prefix? A prefix is simply the starting part of a word. For example, in the word flower, prefixes are f, fl, flow, and so on. Now the goal is, we need to find the longest starting sequence of characters that is shared by every string in the array. Let's take an example. Flower, flow, flight. All of them start with f, then l. But after that, the characters start to differ. So the answer becomes FL. Another example, dog, race car, car. Hey, even the first characters are different, so there is no common prefix. In that case, we return an empty string. So in simple terms, we keep comparing characters from the beginning of all strings, and stop as soon as we find a mismatch. Here is the implementation of the brute force approach. We loop through each character of the first string, and compare it with all other strings. If any mismatch occurs, we return the result immediately. Here, you can check out the solutions in Python, Java, and C++. Pay close attention to both the brute force approach and the optimized solution for each language. Let's analyze complexity. Time complexity is O, n times m, where n is number of strings and m is length of the smallest string. Space complexity is O, 1, since we are not using extra space. Now let's optimize the solution. Instead of comparing all strings, we sort the array first. Then we only compare the first and last string. After sorting lexicographically, the most different strings come at the ends. So comparing only these two gives us the answer. Now we compare the first and last strings. We check character by character and find the common prefix between the m. At index 0, match. At index 1, match. At index 2, mismatch. So the prefix is FL. Now let's look at the optimized solution. First, we sort the array of strings. Why sorting? Because after sorting, the most different strings will be placed at the beginning and the end. So instead of comparing all strings, we only need to compare the first and the last string. Next, we initialize a pointer I to 0 and start comparing characters of both strings one by one. As long as the characters match, we keep moving forward. The moment we find a mismatch, we stop. Finally, we return the substring from index 0 to I, which gives us the longest common prefix. Now, why is this approach faster? Because we are only comparing two strings instead of all strings. Also, there is no repeated scanning. We find the prefix in a single pass, even though sorting takes O n log n. The prefix comparison is very fast, making this approach efficient in practice. Overall, the time complexity becomes O n log n plus m, and space complexity remains O, 1. Complexity? Time is now O n log n, because sorting dominates. But space? Still constant. Trade-off: we pay a little more upfront to avoid checking every string later. Worth it? Often yes, especially if the prefix is sheer. T. Side by side, brute force is O n times m, optimize is O n log n. Which is better? Depends. If n is huge and m is small, brute force wins. If m is large and n is moderate, optimize wins. Know your constraints. Choose wisely. Pro tip for interviews: always explain brute force first. Show you understand the problem deeply. Then, pivot to optimization. Show you think about scalability and trade-offs. Interviewers love candidates who communicate clearly and evolve their solution.